Right, welcome back. Let's do question 4a. Prove the theorem that states that the angle subtended by an arc at the center of the circle is 2 times the angle that is subtended at the circumference by the same arc. We are required to prove that angle COB is equal to 2 times angle CAB. So we have these two angles here, angle COB. This is angle COB. This angle is 2 times angle CAB. You see that these two angles are subtended by the same arc CB. They are subtended by the same arc CB. And then angle COB is subtended by this arc CB at the center of the circle. And then angle CAB is subtended by this arc at the circumference. You see that? So this angle COB is 2 times angle CAB. So before we look at the proof, I want you to remember these two concepts. Right. The exterior angle of a triangle and the angles opposite equal sides. Just remember those two. Right. The exterior angle of a triangle, we say that, let me just draw a triangle here. This is triangle. Right, then this is triangle. Let's call it triangle A, B, C, and then put D there. So we're saying that this angle here, the angle CAD, is equal to the sum of this angle and this angle. Remember that, okay? So that's the exterior angle of a triangle. And then the other one is the angle opposite equal sides. Okay, they don't look to be, they are not equal, but it's fine. So A, B, C, D, let's say this one is E, F, G. Right, let's say this side, these ones, they look like they are almost equal. Let's say side FE is equal to side FG. Then the angles E and G are going to be equal. These are angles opposite equal sides. Now, if you look at this circle here and the dotted line, do you see an isosceles triangle? We can see that a triangle AOC is an isosceles triangle, right? AO and OC are radii, so it means they are equal. So it means this angle here and this angle here are equal. You see that? So these two angles are equal because these are angles opposite equal sides. Again, if you check this angle here, this is an exterior angle. You see, this is an exterior angle of a triangle. Exterior angle of a triangle. This is the triangle. See that? This is an exterior angle of a triangle. So meaning that this angle is equal to the sum of this angle and this angle. See that? So those are the concepts we're going to use to prove this theorem. Okay? Right, let's go to the proof. Let's go to the proof. Okay? Right. So remember, every proof of a theorem involves construction. You have to know what you have to construct. So now we're going to construct a line from A that we're going to pass through the center O. That's the construction if you're proving this theorem. Right, angle at the center is 2 times the angle at the circumference. So you construct the line like this, and then now we can see, let's name our angles. So we have angle, let's call this one angle O1, and then angle O2, and then this one is angle A1 and angle A2. Right, so now if we check, what can you say about angle O1? Angle O1 is an exterior angle of a triangle. So meaning that the sum of A1 and C will give us angle O1. Okay, right. So we can write that angle O1 is equal to angle A1 plus angle C. Why? Exterior angle of triangle. Right. Okay. And then what can you say about angle A1 and angle C? Angle A1 and angle C are equal. So it means that angle A1 is equal to angle C. Why are they equal? These are angles opposite equal sides. These are angles opposite equal sides. So it means here where there is C, we can replace this C with an A because they are equal. So we can say, therefore, angle O1 is equal to angle A1 plus angle A1 because we can replace C with angle A1 since they are what? Since they are equal. And then therefore, angle O1 is equal to 2 times angle A1. You see that? So here we can put 2 times angle A1. Right. Similarly, you can do the same thing on the right hand side here. Let's just do everything. Okay. Right. If you check, this side is equal to this side, or A is equal to OP and also equal to OC. So again, A2 is the exterior angle. If we add, now I've indicated as if these angles are equal. So let me put 3 here so that they are different. Then I put 2 here. Let me put a star here or a dot here to show that this angle is equal to this angle. Right, okay. So now, so we can see that angle O2 is equal to the sum of angle A2 and angle B. So we can say angle O2 is equal to angle A2 plus angle B. Right. Again, same thing, exterior angle of triangle. Right, but we're saying angle A2 and angle B are equal. Angle A2 is equal to angle B since they are angles opposite equal sides. Angles opposite equal sides. So we can replace angle B here with angle A2. Okay, so therefore angle O2 is equal to angle A2 plus angle A2. Okay, these angles are equal, so we can put angle A2 where there's B there. So therefore angle O2 is equal to angle 2 times A2. You see that? So here we can say 2 times A2. Okay, right. And then if you check angle ACAB is equal to angle A1 plus angle A2. And then angle COB is equal to angle 2A1, 2 times angle A1 plus 2 times angle A2. Okay, right. So angle COB is equal to 2 times angle A1 plus 2 times angle A2. Okay, this whole angle here, this whole angle. Okay, angle OCB. And then angle CAB is equal to angle A1 plus angle A2. This whole angle here. That is angle A1 plus angle A2. This whole angle here. Okay, so now we can clearly see that therefore angle COB, let me write again here, angle COB is equal to 2 times, let me factor out 2 here is 2 times angle A1 plus angle A2. We factored out what? Angle A1, so we factored out 2 here. So here if you check, this is equal to C, angle CAB. So, yeah, it should be B, sorry. So it should be C, angle CAB. Therefore, angle CAB. No. Okay. Therefore, angle COB. Angle COB is equal to 2 times. And then we replace this whole thing with what? With angle CAB there. Is equal to 2 times angle CAB. You see that? Okay, that's what you're supposed to do there. Right, we have proved that the angle at the center is equal to 2 times the angle that is subtended by the same arc. at the circumference. Okay, so that is the theorem there. That's how we prove it. Okay, right. We'll meet when we do question 4b1.